let's try quickly launching a rocket in Kerbal Space Program. We've got a rocket here. This is a simulated communication satellite, and we are going to use a script using Kerbal Operating System, KOS here, in order to launch this rocket into space. So Kerbal Operating System simulates a sort of computer on the rocket in the game. We've got this console here, and it's got a simulated hard disk on the rocket, a simulated computer on the rocket. We can interact with that computer through this sort of MS-DOS style interface. So for example, if I type list here, that'll show us what files are on the rocket. We find out that this rocket has a 5 kilobyte hard drive. That's not a lot of space, but it's enough for us to do useful things. So I'm going to go ahead and copy a launch script from our archive, which is not on the rocket, so we've got infinite space in the archive. We're going to copy it over onto the rocket hard drive. Copy file. Copy path. The thing is called copy path. I'll eventually figure this out. Copy path. Then we type list, and we find out that the launch script launch.ks is 600 bytes, and therefore we only have 4,400 bytes left on our simulated hard drive on this rocket. That's fine. To run it, we say run launch, and the rocket is going to start firing its engines. We've got 3 engines here on the rocket. We have a central liquid fuel engine, 2 solid rocket boosters on the sides, and this launch script is going to use the absolute simplest method to put a spaceship into orbit. So the plan to put a spaceship into orbit is the first thing we're going to do is we're going to accelerate up. We're going to accelerate up until the apoapsis of our trajectory, or how high we're going to go, is sufficiently high that we'll be in space. And I think for this particular mission we're going up to 150 kilometers, which is well outside the atmosphere on Kerbin here, this planet that we're launching off of. So we're going to keep burning until we have an apoapsis of 150 kilometers. Our actual altitude is shown here. We're only at 33 kilometers when we got over 150 kilometers. So we stopped burning, and that means we're not accelerating anymore. In fact, we're slowing down due to gravity. You can see our apoapsis is falling because as we slow down due to gravity, the maximum altitude that we're going to reach is going to get lower. But as we wait to get to the altitude where we're going to do our next maneuver, we're going to slowly have the rocket point itself sideways. This rocket has some cheaty physics way. I think we're claiming that there's reaction wheels in there. There's some slightly physics cheaty way to allow it to tilt even though it's not burning a rocket. And so we can see it slowly tipping over to the side. It's, your perspective is it's tipping over that way. It's tipping over to the side so that when it does its next burn, it'll be able to burn that way. Burn that way. Because once we're up high enough, the next step in putting a rocket into space is go fast enough sideways that when we fall back down towards the planet, we miss, and instead we end up in orbit going, that way around the planet. So that's our plan, and we're going to start doing our orbital burn to get into orbit once our actual altitude here reaches 140 kilometers. And rather than wait, we actually have a time acceleration feature we can use. Nope. Yes, sorry. I want to slow back down, because when we get to 140 here, it's going to do step forward, go sideways. Now we're burning sideways. We're burning sort of east is the direction we're burning. And we're going to burn until our periapsis, or the lowest point in our current trajectory, is high enough that we won't hit atmosphere. Oh no, we ran out of fuel, and our rocket is shooting parts off. That's how a multi-stage rocket works. It's getting rid of the excess engines and fuel tanks, and now we just have this little tiny fuel tank here, which, this little tiny fuel tank here, this little tiny engine, which will allow us to burn some more and get some more velocity in the appropriate direction so that we can be in orbit. You can see over here that our horizontal speed is increasing, and in Kerbal Space Program, the orbital velocity is around, we're going up to around 1,000 meters per second. I think orbital velocity is around 2,200 meters per second. So we have to go a little bit faster. And again, we can use time acceleration. In this case, we have to use time acceleration that doesn't turn physics off, but we can use time acceleration to make this happen a little faster. So now we're doing time twice as fast as normal, 3 times as fast, 4 times as fast. Nope, it didn't give me a warning. It may give you a warning there, but time is now running 4 times as fast as normal. And we can see that the rock is falling down at 250 meters per second back towards the planet, but we're still at 140 kilometers. So hopefully we'll get up to that orbital velocity and a periapsis above, I think, 120 kilometers before we hit the atmosphere. Because hitting the atmosphere is unfortunate. The atmosphere is at 70 kilometers. In any case, the important thing here is not necessarily the details of launching a spaceship in Kerbal Space Program. The important thing is that I haven't been clicking things with the mouse except to move around the camera view. We're in orbit, our periapsis is above 70 kilometers. But I haven't been clicking except to move around the camera view, and I haven't been pressing buttons, except I did press buttons to time accelerate. I'll de-time accelerate now. Looks like we've run out of fuel, and we ran out of fuel before we got into the orbit that we wanted. We're now in an eccentric orbit, but this spaceship is never going to fall back down. It's above the atmosphere. In Kerbal Space Program, we have a hard line where the atmosphere ends at 70 kilometers. It's not quite how it works in the real world, but it's good enough for our robotics class simulation where we only kind of care about the actual mechanics of spaceships, just enough to be able to write interesting control programs. And we did, in fact, launch this rocket using a script and not manual piloting. So here's our orbit after that launch. Not a circular orbit with the planet here, and we're 75 kilometers off at the close point, and we are 3,000 kilometers, 3 million meters out at the top of the orbit. So we'll have to work on this control program if we want to get a circular orbit. But we do have a script that gets us into orbit, and it's now trying to find more engines and fuel so it can raise the altitude forever. In any case, we've successfully gotten into orbit, and that's how we're going to be simulating rockets with Kerbal Space Program.